All right, today's topic is a thing called translations. What's a translation? A translation is basically when you move something. Like, let's have a triangle. If I take this here triangle and I move it over to there, that's called a translation. Or if I move it over to there, that's called a translation. Or, I can move it wherever the heck I want. It's called a translation. I'm keeping it the same shape, the same size. I'm not spinning it or anything weird. It's just exactly the same shape. I'm just moving it. That's called a translation. Now you can do that with shapes. You can do that with graphs. You can graph various things. Hey, I'm going to graph whatever I'm going to graph. There, I graphed it. Well, just picture trying to, you could take that and slide it around on your graph paper somewhere. That would be called a translation. And so that's what we're most interested in, is translating graphs. And actually, a little bit further than that, I think it's easy to figure out. Hey, what happens if I move that to the right? Well, it ends up over here, right? That part's not so hard. But what we want to focus on is what happens to the equations. That's not the graph of absolute value of x, but let's say it was the graph of absolute value of x. Well, this would be the graph of what then? Probably some kind of absolute value, but what then? How does the equation, how does the formula change, in other words? We want to take a look at that as well. So, we're going to start with a function we all know and love. Good old absolute value function. We've seen this one. And just to be official, I'm going to make a quick little XY graph. I don't think it has to be that big. Maybe I'll just do like, I don't know. How about the point? -4, 0, and 4. I think 3 points will do us. When you plug in -4, of course, you take the absolute value and get 4. When you plug in 0, you get 0. When you plug in 4 and take the absolute value, you get 4. So, you remember what this looks like, right? So, when you plug in x equals -4, that's over here. You come up to y equals 4, that's up to here. You give yourself a nice little point. When you plug in x equals 0, y equals 0. When you plug in x equals +4, y equals 0. We remember that it has a vertex, that's what we call this pointy part here, at the origin, and then it's kind of like two straight lines going up at 45 degrees, kind of like this. That's the absolute value function. And if I drew it right, you would see the... In fact, let me try to draw it right. Just for fun, I'm going to try to draw it right. I'm going to try to draw it so that it's actually going through the point -1, 1, -2, 2, -3, 3, -4, 4, -5, 5, and so on. There, that looks a little better. Anyway, that's what the absolute value function looks like. Cool, right? All right, what is this function? Notice we're building a new function. We're calling it g. And we're calling it g, but how are we defining it? We're saying we'll take that function f of x, this one, the function f of x is this actually, and add 2 to it. So in other words, g of x is going to be, again, take f of x, which is this, and add 2 to it. That's what the function looks like. That's our new equation. Now, if you wanted to make an xy table real quick, maybe I'll plug in the same 3 values for x. What would happen this time? Well, if I plugged in a -4 here, took the absolute value, I'd get 4, but then I'd add 2, it'd be 6. If I plugged in a 0 there, right there, absolute value 0, 0, but then I'd add 2. And if I plugged in a 4 right there, absolute value of 4 is 4, but then I'd add 2. Notice where these points are. When x is -4, I'm up at 6. I'm up here. When x is 0, I'm up at 2. When x is 4, I'm up at 6. And I think it's pretty easy to convince yourself. Graph a few more points if you have to. But basically, this new graph is going to look like this. Okay? So, what's the effect? How would you describe this effect? This, what color is that? Orange-ish? The orange-ish graph is the blue graph changed how? It looks like we took the blue graph and translated it up. Translated it. We moved it. We moved it specifically in this direction. We moved it up by 2. If you look at any point on the blue function, move that point up by 2. Any point on the blue graph, move that point up by 2. I do mean any point on the blue graph, you move that point up by 2. So that's what this is doing. When you add 2 to the function, what's it going to do to the graph? it's going to shift it up by 2. So I'm going to erase that just to kind of get it out of the way. Not that blue stuff. Got to put the blue stuff back. And trying to be more or less careful over here. Yep. Okay, so that went up by 2. I'm going to write that in blue. The effect of this plus 2 was to move the graph of f, the original graph, move it up by 2. Maybe you've got a pretty good guess what this is going to do, but I'll let you think about it anyway. This says we're going to build a new function. The new function, by the way, has got a new name. It's called h of x. But this new function is you take the f of x from before that we defined over here. You take that and you subtract 2 from it. So you take the f of x function, which is this, absolute value of x, and you subtract 2 from it. So h of x is equal to this. Okay, so this is kind of like instructions for how do you want to change your code. This is saying, change your code, change your function. How do you want to change your function? You want to take your function and you want to, well, take your function and subtract 2 from it. So notice that's exactly what I did. I took the function, which is this, right? Put it there. And then I changed it by subtracting 2. Boy, I love being able to erase stuff. Okay. So if you want it to be kind of go carefully here, you could make another xy table. Let's put the same values for x in, -4, 0, and 4. If you plug in a -4 here and take the absolute value, it's a 4, but then you subtract 2, it's a 2. If you plug a 0 in here, it's 0, and then you subtract 2. If you plug a +4 in here, it's 4, but then you subtract 2. And look at the points we're getting this time. When x is -4, y is just 2. When x is 0, actually, y is down here at -2. And when x is 4, we're at 2. And you could plug in more points if you need more convincing, but I think it's, I think we can bet that it's going to do this, right? And so this green function, how does it compare to the blue function? Doesn't it look like the same shape and everything? Hasn't been spun or anything like that. Hasn't been, twisted or whatever. It's the same thing, except it looks like we just kind of moved it. Translated it down by 2. And notice every single point, no matter where you go, every single point on the blue function has been shifted down by 2. So that's what this means, down by 2. And so I'm going to actually write that. Down 2. This -2 has the effect of shifting it down by 2. And so there, we've just had 2, what we call transformations. That's a slightly different word. Translation, it turns out, is one kind of transformation. We'll look at more transformations as the days go by, like reflecting and so on. But for today, we're just moving things around. We're shifting things around. Translations, up, down, left, right, translations, that kind of stuff. So on this first page, you can kind of see this is how we do up and down. You want to go up. You want to go up by 2, add 2 to your function. Take your function, add 2 to it. You want to go down, subtract 2 from your function. Take your function and not add 2, but subtract 2. Okay, so that's how that basically goes. Go back to blue. Let's go to page 2. What are we going to do now? Well, I'm going to take that same function again, absolute value of x, and I suppose there's no reason we couldn't make the same xy table. Right, you remember this thing is a V shape, so it doesn't take that many points to nail down the V shape. 3 points seems good. So again, if you plug an absolute value in here, absolute value of -4 is 4, absolute value of 0 is 0, absolute value of +4 is 4, and so on. So what's that look like real quick like? When x is -4, we go up to 4, that's about here. When x is 0, y is 0. When x is 4, y is 4, just about here. You've got a straight line going up at 45 degrees on this side, and then you've got a straight line going up by 45 degrees on this side, and there's your basic function, absolute value of x. I'm calling that f of x. F of x equals the absolute value of x. Now, this is a little different than what we did on page 1. Remember, page 1, what we did is we added 2 like this. the 2 was out here. Adding the 2 was out here. Here's the function over there. We added 2 outside the function, so to speak, or we added it to the function. This is different. This is saying go inside the function. Go inside the function and change x to x plus 2 inside the function. Go in the function. Remember, if you put it in parentheses, you plug it in, right? Plug that in. That's a very different game. That's not just adding 2 to the function. That's adding 2 inside the function, so to speak. So you go inside the function, in there, inside there, and where you see the x, you replace it with an x plus 2. Do you see how that's very different? By the way, that's not f of x. That's j of x. Sorry about that. We're defining a new function called j. J of x is, what is it? Take the f function. Okay, I got the f function. Here's my f function right there. Go and plug in, go inside and plug in, make that x into an x plus 2, like that. Okay, that's what those instructions are saying. So make sure you keep a sharp eye, like what exactly is this asking me to do? It's not, again, it's not asking me to just add 2 to the function. Nope, nope. If that's what I meant, I would have written it this way. It's not what we meant. We meant go inside the function, change the x to an x plus 2. It looks like that. Like that. Okay. Now, in order to graph this thing, we could try to take a guess. Is that going to go up, down, left, right? But let's just kind of be sure. Let's plug in the same values for x that we did before. Now, if I plug in a negative 4 here, notice what's different. First, I'm going to add 2 to it. Then I'm going to take the absolute value. So a negative 4 plus 2 is a negative 2. And when you take the absolute value of negative 2, you get a 2. Okay? So again, it's a kind of a different sequence of events here. I want to plug in a 0. Well, that's going to be 0 plus 2. You add 0 plus 2, you get 2. And then when you take the absolute value, you get 2. Am I doing this right? When I plugged in negative 4, yeah, I get 2. Okay, this is going to be weird. So if I plug in a positive 4 instead. Okay, well, 4 plus 2 is 6. And when you take the absolute value of 6, you get 6. Okay, so those 3 points, we might have to plug in more points to really see this. But let's at least plug those 2 points in, those 3 points in. When x is negative 4, we're up at 2. When x is 0, we're at 2. Huh? Okay. When x is 4, we're at 6. Here's my prediction. Since I'm expecting a v, and since it has to go through those 2 points, it probably goes down to like there, and then it turns and starts going up to here. That's my guess. You want to verify it? Let's plug in x equals negative 2 and make sure that's the point that we really get there. If I were to plug in a negative 2 here into my function, negative 2 plus 2 is 0. Yeah, you take the absolute value of 0, you get 0. Yeah, we nailed it. There it is. So there's our new function j of x. So here's the j of x. This blue thing was the original f of x, okay? Sure looks like the same shape, don't it? It's the same exact shape. We call that a translation. It just got moved. It got slid. Question, which way did it get slid? Well, you start on the blue. Looks like you go that way. I suppose I should draw that in the other color. That way. See, the vertex ends up. The vertex is kind of a dead giveaway. The vertex was here. Now the vertex is over here. So it's sliding to the left. And notice every single point on the blue function, wherever you care to go, you can go left to and find a point on the other function. Start on the blue function here, slide left to, you're here, and so on. It's a left by 2. So let's write that down. I'm going to kind of go like this. I'm going to make some space here, and I'm going to say left by 2 is what that does. Now I want to point something out. A lot of people see, well, if I'm adding 2, isn't adding, the positive directions that way, right? Shouldn't it go to the right by 2? No, it didn't say right, it said left. It came out left, right? The graph doesn't lie. It's going to the left. So make sure you don't let that throw you, right? We're replacing x with x plus 2, and that makes it go to the left. Okay, go to the left. I'm willing to bet that you've got a pretty good guess what that's going to do. We're not adding 2, we're subtracting 2, so we're kind of doing the opposite. So we're not going left 2, we're going to go right 2. Let's just, if you want to make a nice little XY table for yourself, go right ahead. But you're going to find that it goes right by 2. If you want your graph to translate to the right by 2, that's how you do it. You would take the equation and replace it with x minus 2. In other words, this equation would be take the absolute value of x and change it. Change it how? Make the x into an x minus 2. And that will go to the right. It looks like I forgot to kind of write that over here, right? J of x is going to be take the absolute value of x and okay, now I have to do one of these things. Move over. Okay. That would be how our j of x equation looks, is we took the function and we went inside the function, and wherever we saw an x, we replaced it with an x plus 2. So instead of the absolute value of x, it's the absolute value of x plus 2. Okay, that's our equation. Again, if you make it an x minus 2 instead, your graph is going to move to the right. So if you want to prove it to yourself, you can plug in some values if you want, but I guarantee this is what it's going to end up looking like. So it's going to go to the right by 2. Any point on the blue function is going to get moved to the right. And I do mean any point on the blue function gets moved to the right in order to form this new function k of x, which is this. Okay, so I think we're ready to summarize now. What color do we summarize in? We'll summarize in blue, I suppose. Summary. If you change the equation f of x by doing this to it, this will move graph of f up by 2. So if you made a new function by taking some old function and adding 2 to it, this new function, give it a new name, g of x, would look the same. If you graphed it, it would look the same as the graph of x, with the exception of everything's been split up by 2. Okay, so that's kind of what's going on with this stuff. And you could write here too, if it was f of x minus 2 instead, well, you would go down. And we had 2 others. If you did this, remember, plus is going to make you think it's going to the right, but in this case it really does go to the left. Left by 2. And if you did this, you would go to the right by 2. So again, keep in mind the differences here, right? This is taking the function as is, adding 2. This is taking the function and changing it by going inside, making the x into an x plus 2. So you have to kind of keep clear which kind of change am I making. Am I adding to the function, subtracting from the function, or am I going inside the function, adding to the x specifically, or subtracting from the x specifically? So now we can do a quickie quiz. Quickie quiz. This is where this stuff can get really handy, is you can, well, for example, you can look at something like this. Now this is kind of like a square root of x, except it's getting moved, right? Now how is this being moved? Well, looks like we have to go inside the square root here and do an x minus 3. This would be going right by 3. Okay, minus means right by 3. So in the back of your mind, you're thinking about the standard square root function. When x is 0, you take the square root and you get 0. When x is 1, you take the square root and get y equals 1. When x is 4, you take the square root and get y equals 2, and so on. Remember, these are some of our standard points. Except that's not the points we're going to get. We're going to actually get to the right by 3. So take this point, move it over there. Take this point, move it over there. Take this point, move it over there. Here you go. That's our function right there. Just move the whole darn thing to the right. So see how quickly we were able to build that. We knew how to do square root of x function, so that's what these 3 points are. They go on the standard square root of x function. But what we're actually graphing is something that's moved to the right by 3. So the actual points end up over here. We end up graphing this thing here. And you could probably erase those points now if you wanted to. But, okay, what's going on with this one? Well, first, think back to what 1 over x looks like. less than 56. What does 1 over x look like? That was the one that has kind of like crosshairs. So I'm going to kind of go like this. I'm going to say, remember it had crosshairs like this. And it was kind of like when x is 1, y is 1. When x is 2, y is a half. Why? Because it's a reciprocal function. If you plug in 2, you get 1/2. If you plug in 1/2, you get 2, because that's the reciprocal. And then also you ended up with points over here. If x is -1, the reciprocal is -1. This one is if x is -2, the reciprocal is -1/2. If x is -1/2, and anyway, this was the original function, but that's not the one we want. What we actually want is we want the one that is, notice again, you would play with this function by going inside to where the x is and making x an x plus 2, which would mean left by 2. So the real function is not quite the one I've drawn. I'm going to try to draw that thing shifted over by 2. Now, if you don't mind, I'm going to start fresh. This is actually a good trick that you might want to try to pick up. So I'm going to start fresh, and I say, okay, left 2, huh? Well, the crosshairs used to be on the axes, but I guess I have to move it to the left. So my asymptote's going to be over there now. Now, a translation means we're not changing the shape at all. The shape is exactly the same. So it used to be I would plug in 1 and get 1. Well, just kind of do this. Pretend that's like your new origin. Over 1, up 1. Over 2, up 1/2. Over 1/2, up 2. And then on this side, it's kind of the same thing. It has exactly the same shape, in other words. So it has to look something like a this. There it is. Oh, let's see. What's this one? Remember what x squared looks like? That's a nice parabola. You would plug in x equals 0, get 0. You would plug in x equals 1 and get 1. And if you plugged in x equals -1, you get 1, right? Because -1 squared is also 1. Plug in 2, you get 4. If you plug in -2, you get 4. Those are your basic parabola points. But this is not that. This is down by 4, because the -4 is, if I wanted it to move it to the right, I'd have to put the take the x itself and make it an x minus 4 and then square it. That would go to the right by 4. But that's not what this is. This is outside my function, so to speak. So I'm going down by 4. So the real thing is going to be down here. So take this, move it down 4. Over 1, up 1, over 1, up 3 more, right? This point is down 4, this point is down 4, and so on. And here's our new parabola. It's shifted down by 4. And just to remove the clutter, we could just kind of get these out of the way. Maybe make a note to self. I went down by 4. Okay. Ask yourself what that is. Well, that weird looking thing in here, that's called the floor function, you might recall. So the floor function is that set of steps. You start at the origin, and then you just kind of go over 1, up 1, and you keep making a set of steps going forever in both directions, right? That's your basic floor function. Come on, you. That's your basic floor function. Looks like that. But we don't want that. We want to add 2 to it. So we're going to go up by 2. The whole thing's going to go up by 2. So what I can do is I can just kind of erase this stuff and say, okay, I was starting at the origin, but since I'm going up by 2, I'm going to start here. But it's still going to be exactly the same shape. That's what makes translations kind of fun. Once you know where to start, you can just draw it all the same. So solid dots on the left, open circles on the right, and so on. Hope you're liking the shortcut, man. Shortcut. Oh boy, it's the end of our lesson and everything. Okay, so summary was right here on the top of this page. This is the part that you just got to sort of internalize. If you have a function, take the equation, whatever the equation is. If you add 2 to the equation, the graph's going up. If you subtract 2, the graph's going down. If instead you go inside the equation, which is kind of like what we were doing here, if you go inside the equation, x plus 2 will make you go left, not right, left, and x minus 2 will make you go right. X plus 5 will make you go left 5, x minus 2 will make you go right 5, and so on. Translations, that is today's deal. Yay, okay, cool, that works.